Hello friends, this video on p block elements part 24 is brought to you by examfear.com. No more fear from exam. So the question is the BA bond length in BF3 and BF4 minus is different. Why? So you see BA3, we talked about BA3 actually, if we have this BF3. So what happened is this guy's boron is sad because it has less electrons, it has only 6 electrons. So what will happen is boron will give some electron to, fluorine will give some electron to boron, correct? And thus it will form a bond, and this is because of pi back bonding, correct? Because of pi back bonding, which exists more in case of fluorine, and this back donation occurs. With this, if you see, the BF bond actually acquires a double bond characteristic, since there is a transfer of electron here, right? So BF bond acquires almost double bond characteristic. Since this is double bond characteristic, the size of the bond decreases, right? The bond size decrease and it becomes 130. But in case of BF4 minus, if you see BF4 minus, this guy is already happy. This guy is already happy. This boron is already happy, right? Why? Because it has 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. So there is no transfer of electrons from fluorine to boron. So there is no double bond characteristic. All single bond. So the length is there. This is 143. Right? And in this case, the bond length or bond size or the bond length decrease and becomes 130. So if you see BF3, the bond length decrease because of pi back donation, pi back bonding. The next question is BCl has a dipole moment, but BCl3 as a molecule has no dipole moment. So if you see the BCl3 molecule, it's a polar in nature. Sorry, planar. Right? This is planar. Once again, clearly. Yeah. So though it has dipole, though all these has dipole actually, right? But the net dipole is 0. This angle is 122. Since it is planar, the resultant dipole is 0 because if you see this guy, and this guy, the resultant is 0 because this guy is x component and this guy is y component. They'll cancel each other, and these two add, they'll cancel this part. So overall, you apply the laws of physics, you'll see that the net dipole is 0. So the question is aluminum trifluoride is insoluble in HF but dissolves in NaF. First try to understand what is the difference between HF and NaF, and it talks about solubility. That means we talk about the kind of bond it is ionic or covalent bond, correct? Because we know that ionic elements dissolves in ionic solvent, and same with the covalent. So if you see HF is what is a covalent, and NaF is what? Na plus NF minus, that is ionic. It says as aluminum trifluoride is not soluble in HF but in ionic, correct? So with this, what is aluminum trifluoride? Is it ionic or covalent? This guy is also ionic, right? It can easily gives ions. So if you see ionic dissolves in ion, correct? So if you see you have NaF react with AlF3, it forms Na3AlF6. Sodium hexafluoroaluminate, soluble. Why? Because these both are ionic actually, correct? But it will not dissolve with HF because HF is covalent, correct? Now the question says once we have got the solution, in this solution you pass BF3 gases. Once you pass BF3 gas, you see that aluminum trifluoride AlF3 comes out. Why it comes out? That means BF3 must be replacing AlF6 here. That means BF3 has to be a stronger Lewis acid than AlF3, and that is true. You know that BF3 it is electron hungry. It is a strong Lewis acid, correct? You see the BF3 structure. It is electron hungry, 6 electrons only, right? 2 plus 2 plus 2, electron hungry. So it is strong Lewis acid. But AlF3, it's not that case. So BF3 will replace this AlF3 in this, and you get AlF3 out. If you want to write the reaction will be something like this. You have Na3, AlF6. This is the compound we have formed there, right? When you react with BF3 to form Na BF4 and So this is the balanced reaction. The question is why carbon monoxide is poisonous. I told that this carbon monoxide forms a very complex compound with hemoglobin. So if you see, we have hemoglobin. So the typical reaction is when it reacts with oxygen, it forms oxyhemoglobin, right? And this is something which supplies oxygen to all parts of the body, right? It is formed in the lungs and it supplies oxygen to all parts of the body. Now what happens is hemoglobin combines with carbon monoxide. What it forms is carboxyhemoglobin. In fact, this is not the this reaction is a forward reaction itself. This is not a what do you call it? Equilibrium reaction. It's almost forward reaction, and this is very stable actually. That's why we see it's only in the forward direction. It's almost 300 times stable than this guy, oxyhemoglobin. Thus, the hemoglobin is now used to create carboxyhemoglobin, and this won't go off, right? So, where will this be formed? This won't be formed because whatever hemoglobin I had, this was carbon monoxide consumed this to create carboxyhemoglobin. It's very strong, very stable. It won't revert back and will have deficiency of hemoglobin. If we have deficiency of hemoglobin in the body, we can't create oxyhemoglobin. If we can't create oxyhemoglobin, the body will suffocate due to lack of oxygen, and sometimes the human body dies also. So it's very risky. How the excessive carbon dioxide is responsible for global warming? So as we have told that carbon dioxide traps heat or sunlight. So what is happening is, due to more pollution, more factories, less trees, due to all these, the carbon dioxide concentration is going up in the atmosphere, right? It has to be 21% is a decent percentage. So it is 21% is okay, but it has to, sorry, it is not 21%, 21% is the oxygen. So it has to have some percentage. Now if it is increasing because of the more pollution, more factories, less trees, what is happening is more and more heat is getting trapped because carbon dioxide traps heat, right? More and more heat is getting trapped, and thus overall the earth is becoming hotter. And this is nothing but global warming. And with that, the scientists are predicting that with this, all the glaciers may melt. If the glacier melts, all the coastal regions will drown in water. This is a critical issue actually. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.